Okay, now let's find the vertical and horizontal asymptotes from a rational function. Here's a rational function here. We want to find the vertical and horizontal asymptotes. Let's start by finding the vertical asymptotes. And I got a nice little list here of how to do it. The first step is to factor. The next step is to simplify, if possible. Sometimes you can't. And the last step is to solve the denominator. The denominator actually tells you what the vertical asymptotes are, where it's more the numerator that figures out the horizontal. Kind of. Not totally, but kind of. So let's start by factoring this whole expression up here, the x plus over x squared minus 2x minus 3. Well, to factor it, we got to factor the top. Really, you can't factor. We just got to factor this bottom, the x squared. Let's factor that right over here. X squared minus 2x minus 3. I'll put my little x thing in. Take this minus 3, put that there, put minus 2 there. What times what is negative 3? They add together would be 2. Negative 2 would be 1 and negative 3. So my factors are x plus 1 from this and x minus 3 from that. Okay. Factor my numerator. I'll put that right here. And then I'll just take this x that was on top in the beginning, put it right down there. There we go. So we have it all factored. Now the question is, we got to simplify. So we got to ask, is there anything you can cancel on top or bottom? Is there anything we cancel? Well, some might say you can cancel this x with this x, but you can't. You got to cancel whole factors. You can't do that. Now if this was, I'm just saying, but it's not. If this was x plus 1 like that, you could cancel it off with that, but it's not again. Okay? It's not. So you can't cancel it. I'll control Z that. Can I control Z? Doesn't seem like I can control Z. Let's try it one more time. Control Z. There we go. So this is it. This is our function. We can't simplify it. Step 2 done. Just put a little check there. Okay? And now we have to solve the denominator. By solving the denominator, we want to set the denominator equal to 0. So we're going to take this denominator and we are going to bring it down here. And when we bring it down here, we're going to set it equal to 0. So we're going to have x plus 1, x minus 3 equals 0. So we got to first figure out, how do we make this equal to 0? Because if we can make this equal to 0, then this whole thing is 0, right? This whole thing is 0. So what's plus 1 is equal to 0? Well, in this situation, when x is negative 1, that thing is 0. Now let's take a look at this one. X minus what is 0? What minus, sorry, let's say that again. What minus 3 is 0? Well, in this situation, 3 minus 3 is 0, so our x is equal to 3. So here we got our vertical asymptotes. Our two vertical asymptotes, or the equations for the line, are right here at the bottom. We just wrote them down. It's x equals negative 1 is the equation for one vertical asymptote, and x equals 3 is the equation for the other vertical asymptote. Right there. Vertical asymptotes. Okay? So that's how you find your vertical asymptotes. Now, let's find the horizontal asymptotes. So, there's two scenarios for the horizontal asymptotes. There's scenario 1. If the numerator degree is less than the denominator degree, that's the scenario 1 that we have to figure out. Well, if the numerator degree is less than the denominator degree, then the horizontal asymptote is y equals 0. Okay? It's just y. That's just how it is. And how do we know if the numerator degree is less than the denominator degree? Well, let's look at the numerator. The numerator is this. What's the biggest degree polynomial up here? It's this. What's the degree of it? It's 1. That's the degree of that one is 1. And what's the biggest degree polynomial on the bottom? It's this x squared. What's the degree of it? 2. So the numerator degree is less than the denominator degree. Therefore, this one is y equals 0. Now, if the numerator degree is equal to the denominator degree, this is how you figure out that one. I'll show you an example. Let's say we had 2x squared over 2, no, that's not 2. It's not 2. Over x squared plus 3x plus 5, okay? So in this situation, the numerator degree is 2, and the denominator degree is 2. So what you do now, this is what you do. You look at the coefficients of the biggest power term, okay? So the coefficient, I'm going to do that in blue. No, I already did blue. Purple. The coefficient of this one is 2. And the coefficient of this x term, see this x squared term? It's 1. You don't see it there, but it's there, right? So the equation for the horizontal asymptote is y equals 2 over 1, which is the same thing as y equals 2. And that's the equation for the horizontal asymptote. So just to recap for this one, if the powers are the same, okay, of the numerator and the denominator, the degree of the numerator is the same as the degree of the denominator, you just take the coefficient of the numerator in front of the biggest power term, and the coefficient of the biggest power term in the denominator, and divide the two, and you get your equation for the horizontal asymptote.